Before we end our lesson on static electricity, let's quickly review what we did today. First of all, static electricity is created when two materials that are not good conductors are rubbed against each other. Now in the lesson I said that we need two materials that are not good conductors because we want the charges to build up on the surface of the material. If they are good conductors, there cannot be any build-up of charges. 2. Transfer of electrons results in charged materials. Now the giver of electrons will always have a positive charge, and then the acceptor of electrons will always have a negative charge. We also got to see that like charges repel, unlike charges attract. So if we have two positive charges, as we saw in the polythene rods, they are going to repel each other. If we have one positive and one negative charge, as we saw in the comb and then the paper, we are going to have attraction occurring. Now the force of attraction will only be felt if the materials move closer to each other. If the materials are far away, there will be no force of attraction. But the moment they get closer to each other, the force of attraction will be felt. The fifth point is that the instrument used to measure static electricity is what we call the gold leaf electroscope. We saw that it can perform three main functions. 1. Detecting if a material is charged or not. 2. It can also be used to charge, or we can use certain materials to charge the gold leaf electroscope. And then thirdly, we can use to distinguish between a conductor, a good conductor, a poor conductor, and an insulator. And then the sixth point is that lightning is caused by static electricity. When the clouds form, there is a separation of positive and negative charges. If they are heavy enough, there is a spark of light that occurs between the two charges, or the two different charges. Now the result is the lightning we see when it is raining. That brings us to the end of our lesson on static electricity.